Hey everyone, welcome to our talk on observing and troubleshooting your microservices with Istio. Thank you for sticking around. I know it's the end of the conference. I hope some of you have more energy than I do at the end of these 3 days. My name's Doug.
I'm Isaiah. I'm a software engineer for IBM.
Yeah, we're both core contributors to the Istio project. What we thought we'd do today is sort of walk through just a little bit of an overview of what Istio is, just in case there are people in here who haven't been hearing about it, or service meshes in general. Talk a little bit about the ways that in service mesh and Istio in particular allows you to sort of get better insight into what's going on in a service, even what's going on with Istio itself. And then Isaiah is going to talk his way through a demo on troubleshooting some issues with a proxy that you might have. So, do you want to? So Istio, do you want to click to next? So I think you by now have probably seen this feature slide and heard people talk about Istio, so I won't spend a whole lot of time here. I just wanted to call out a couple things about service meshes that I think help with debugging and observing microservice architectures. And in particular, it's very easy to talk about metrics and logs and traces. I think that's what comes to mind. But one of the powerful things that I think Istio provides as well relates to traffic control, and I've highlighted fault injection as part of this, right? So as you're developing new versions of microservices and ready to roll things out, we can do, makes it very easy to canary, and there was a great talk earlier today about canarying services, do traffic shadowing, traffic splitting, but you can also test failure cases. So if I want to see what happens when a particular service takes too long to respond, I can simulate that behavior very easily with Istio. And so I think that gives you another powerful way, in addition to just looking at dashboards and metrics, to see what happens to services. And you can do that before something goes wrong, which is fairly useful. Just real brief, to talk about the different pieces of Istio, right? We have proxies, we have something that's translating Istio config into the config for the proxies and pushing it out, that's Pilot. We have Mixer, which is an integration point for Istio that is providing policy enforcement and telemetry collection export to various systems that you might want to do for traffic analysis, etc. And then there's a certificate authority called Citadel, which is in charge if you want to turn on Istio auth, and we have an ingress for traffic coming into the mesh, as well as an initializer, which will inject Istio everywhere. So I think I like this slide just because I like to show what Istio is, and I think it's easier to understand this way, so I don't know if it helps other people. So if you think about Istio, right, you have a user client application that knows it is trying to call, say, this Angular service, and that Angular service knows it's trying to call a backend. Everything else should be sort of invisible to each of those pieces. And then there's a couple things that I wanted to point out about Istio in general is that all of the config lives in the API server. So if you ever want to know what's happening or why Istio is behaving a certain way, you can start with looking at the config just by pulling it straight out of the API server. The other thing that I wanted to point out was that the Pilot is pushing all the config and doing the translation to the proxies. And so when you want to find out what behavior is happening, you don't necessarily have to look at the config that Pilot consumes, but you can look at the actual Envoy config and look at their docs as well. The third part is that, and this is what I was mentioning earlier, we are doing automatic telemetry collection on behalf of services. So we're gathering information that we can use to form metrics, access logs, and generate trace data for the service mesh with very little to no need to do that in the applications themselves. And the final bit that I think is sort of interesting to point out is that we're also running Istio on Istio, and so that allows you to use those same standard tools to debug how Istio itself is behaving, and that maybe will come out in the next couple of slides. So yeah, I just wanted to go briefly over the kinds of things that a service mesh and Istio in particular give you to help you understand what's happening on your mesh with traffic. So Isaiah is going to talk through a demo on debugging at the proxy level, so I won't spend a lot of time here. I just wanted to call out that Envoy, and there's been a couple of great talks on Envoy this session or this conference as well about how it was built around observability. And so I think the admin interface is a great place if you're just trying to figure out what's happening. You can look to provide stats for each instance. You can dump the whole config, which, depending on how complicated things get, is worthwhile. I like just looking at the access logs that come straight out of Envoy. Last night when I was just sort of looking at the talk, I noticed there was a bunch of traffic on my test cluster, and I was wondering what was happening, and so I just went and saw, and you can see I'm just getting slammed by just random web traffic. So that's the kind of thing that can help you understand why you might see a traffic spike. There are a bunch of dashboards that are compatible with the default metrics in Istio. They're worth taking a look at. You have mesh-wide dashboards, per service dashboards, and dashboards on Mixer and Pilot themselves, so you can see how Mixer and Pilot are exporting things about their configuration, errors in their configuration, how often they're calling the API server, that kind of thing. So please take a look at those. If you don't want to use the pre-canned queries in the dashboards, you can go directly to Prometheus or another metrics backend and run queries. And so this is an example of, I was playing around and I applied a traffic splitting rule between the 3 versions of the review service, I think. And I just wanted to see that that was actually happening, so you can see that, real quickly I can get a feel for how many requests are going to which place. And so there's that as well. And so then distributed tracing, I don't know how much time we want to spend here, but I think this provides another unique way to look at traffic flowing through your service, because you can see the dependencies between services pretty easily, and where latency and errors might come in. So that's something that's worth mentioning. And finally, logs, like I was saying, we generate access logs for every request that's coming through at each point that it goes through the mesh. And so we have default integrations with things like FluentD, and you hear I'm using that to use Kibana to analyze logs. So that's something to remember. And the final piece that I think is worth pointing out for when you're debugging and trying to figure out what's happening is you can use kube control. You can use it for a number of things. You can use it to see the logs of any of the processes, but also you can use it to get the actual config, like I was saying earlier, for each component, each little subsystem within Istio. And I find that very useful. And I think it's neat because by using the API server, we make that stuff available through standardized tooling. And the other thing that I end up doing sometimes in development is editing deployments on the fly and changing logging levels and scopes for various parts of the system that I want to test while I'm doing development. And with that, I think I'll hand it over to Isaiah.
Yeah, so thanks, Doug. Thanks. Doug gave a very good overview of the high level of Istio, like why you'd want to use it, the basic architecture, and some of the tools that exist for debugging in Istio. For my portion of the talk, I'm going to take a little bit of a dip into some of the implementation of Istio. So everyone's seen like the feature list for Istio. It's pretty long, and it's fairly impressive. It's sometimes not entirely clear how Istio is actually doing these things, and that's usually one of the first questions that I get when people come up to me and ask me. A lot of these features seem like magic, and magic is great as long as it is actually working and doing what you expect. If it's acting in a way you're not expecting, you need to have a little bit of background knowledge to understand the system, actually troubleshoot. So if we're going to talk about debugging and troubleshooting in Istio, we have to start with our proxy, the proxy we use in Istio, which is Envoy. There's a whole host of reasons we use Envoy. First of all, it's battle tested, used in production by Lyft, used by a lot of big name companies. It's also very lightweight, which is incredibly important for a proxy for a service mesh, because you're going to have to deploy that proxy in all your pods. So if it's heavy, it's going to be costly, and then it's going to hurt the overall usefulness of the service mesh. Then the third bullet point, which is it has incredibly good performance. I don't know how many of you watched some of Matt Klein's talks on the internals, but it has some amazing logic and tricks to get very high performance. And finally, it's very important that Envoy provides high dynamic configurability. So for a service mesh where you have these declarative configs that you're sending out to the control plane, and the control plane is applying these to this large host of proxies, you want those proxies to be able to adopt those new configs without any downtime and without dropping old requests, for instance. Otherwise, service mesh is not going to be very useful. So I thought I'd just briefly touch on this point, which is what is a service mesh exactly? If you boil it down to the very basic, overly simplified one bullet point, it's basically a bunch of proxies talking to a bunch of proxies that are all configured from a control plane. And so you see all the behaviors because of the configurations of these proxies. So just to illustrate this, I'm going to go through just a quick example and show how the config actually, the configuration of the proxies actually results in the declarative behavior that you are looking for. So in this example, we have inbox UI service. Think like Gmail, basically, the front page from Gmail. And it talks to a messages backend service where the emails or the text messages or whatever else live. And in this scenario, the operators have decided they want to test out the behavior of the UI when there's a bunch of latency in the network, and make sure that it actually behaves in a reasonable way when that happens. Now, traditionally, you could do this by adding some extra logic in your code, but with Istio or a service mesh, you can do this with config. So you can see over on the left, have a routing rule. This lives out as a CRD inside of Kubernetes. It's very simple. It just says that all requests going to the messages service from the source of the inbox UI with this special header, the special test header, should delay by 5 seconds 100% of the time. And so the way this actually flows is the request starts as it normally would inside the UI, and it's sent as it normally would be to the messages service, but it's captured by the inbox UI's sidecar using IP tables and NAT magic, basically. And from there, since that particular Envoy has configuration that it's gotten from Pilot, which has been listening to Kubernetes and listening for resource definitions like this route rule, it delays that connection, that request, by the 5 seconds, then sends it on across the wire as it usually would be to the messages service. And once it reaches the messages service, it's captured again and sent to the messages service on localhost inside the pod. And then the response is sent back to the inbox UI. And the important thing to emphasize, of course, is this is completely transparent. As far as either service is concerned, all that happened was it sent out a request, and for some reason, it took 5 seconds on the network. So hopefully that shows just a very simple example of how configuration is actually enforced inside of a service mesh via config inside of the proxies. It was a fun example, but there wasn't really any chance of it going wrong, so I'm going to do a live demo and wish me the best. So just a quick overview of the microservices app we're going to be working in. Starting out, it's very simple. Just have ingress, which takes traffic from outside the mesh. And that goes to a Gistbook UI service. Inside the Gistbook UI service, you can enter phrases, and the phrases get sent to a Redis database backend and stored there. And the UI can also show that on like a little wall. What we're going to do is we're going to add a version 2 of the service. And we're going to add in a tone analyzer, so it looks at the tone of the phrase that you're entering. And based on that, it will annotate the phrase and say this is an angry phrase or a sad phrase, and it'll have a little smiley face. And I'll show you how the UI looks in a second. Just to save time, I've already deployed the tone analyzer, but I have not deployed the version 2 of the Gistbook. So here's demo. Let's see. So first of all, I'll just show you how it looks. Very simple stuff. So what I've done for this demo is I've actually done kubectl port forwarding from localhost 15003 to the Pilot API. And the Pilot API has a REST endpoint, which is actually where the envoys call to get their configuration. So if we take a look at it, you can see this is the registration API. So you can see the services in our system. There is the analyzer, because I've already deployed that, and Gistbook, and these are all just a bunch of internal Istio or Kubernetes systems. We notice here inside the array of hosts for Gistbook, we have this .112 or this .12 IP address. And just to illustrate a point, if we do kubectl get endpoints for Gistbook, we can see it's the same IP address. And this is because it's actually, in terms of implementation, it's actually talking to the kube API server to get that information. So we're going to go ahead and deploy this new version of the Gistbook service. So let's see, kubectl create-f, yeah. I'm not going to cat it or anything because it's just a standard Kubernetes deployment with a special label of v2, which we'll use later. So if we refresh a couple times, hopefully in a couple seconds, we'll see that this new endpoint has been added, the .13. That's the cluster IP of the Gistbook v2 service, that instance of that service. Of course, if we look at main page, we can see it shows the new version. So let's do a phrase that has some kind of tone, like I love coffee. And it takes a little bit, but shows this annotation here, which is actually talking to external service Watson. But one thing to notice is if we keep on refreshing, it just kind of randomly bounces between these two versions of the service, which isn't really what you want if you're deploying a new version. You'd want to ideally do a canary deployment and just route like a very small percentage of the traffic to the new version, and then look at metrics to make sure that like it's actually handling it properly. So what I'm going to show is just the current configuration, and then we're going to go through applying a configuration where we send a percentage of the traffic. So the first thing that any traffic in this particular microservice application hits is the Istio ingress controller. So we're going to look at the route configuration for that ingress controller. And basically, the easiest way that I know of doing it is just to go do a kubectl exec on it, and do a ps-x. And I'll show you how that looks in a second here. So this basically shows the running processes inside the container. And you can see there's this pilot agent, which is just a little management process. And then the actual envoy that's doing the proxying. It has a huge number of arguments sent into it. The one we care about, though, is this service node argument. And basically what the service node is it's the name, the unique identifier that each of the envoys is given when it started up inside of Istio. And if we grab it, we can use that ID to look at some of the other APIs that are exposed. So we're going to look at the routes API for port 80 as a ingress type proxy, and for this particular node. So this shows the routing configuration that's actually being used for the ingress controller. It's super simple. All it is for wildcard domain, any domain, we're going to route to this cluster reference. Basically, in the Envoy nomenclature, cluster is just a collection of endpoints and a way of discovering them, and then also a way of load balancing them. And so if we continue on to this next API, which is the clusters API, we can see, clusters. V1 clusters. Oh, I see. 1 second. I'm missing one part of the path. It needs to be for the role of an ingress proxy. So if we look at the clusters for ingress, this is the active clusters for this ingress controller. We can see that same cluster reference. The thing to note here is its type SDS, which is Service Discovery Service, which means that it actually gets the actual endpoints from another API. And then, of course, it's load balance type round robin, which is what we were seeing. And if we grab the service name, we can actually look at the endpoints that Envoy will be getting for this particular cluster. And you can see here, it's the .12 and the .13, which is version 1 and version 2. So we want it to actually be routing based on a percentage instead of just based on the number of endpoints inside the cluster. So the way we do that is just with a simple routing rule. So looks pretty similar to the one we used before. Only thing to note is it applies to the destination of guestbook, so all requests going to guestbook should be routed to, like, say, version 1 90% of the time, and then version 2 10% of the time. So let's go ahead and apply that. All right. And actually, if we go back a couple pages, back to the routes, not to the URL that I was trying to figure out, back to the routes, and refresh, we see that instead of that single cluster reference, we have weighted cluster references and weights given to each of these clusters. And you can actually see version 2 right here in the name for the cluster. I mean, that's implementation detail, but it's still handy. So we go back forward, back to the clusters API. We can see instead of that original one cluster, we have these 2 new ones. And if we grab the service name again and look at the registration API with that particular service name, we can see that it's just the .13, which is version 2 of Guestbook. So let's actually verify this by just pummeling the UI with requests. You can see it's roughly like 10% of the time you see a tone analysis show up. So like normally what you do here is you'd start looking at your metrics and making sure that the Guestbook v2 was actually handling the traffic properly and was healthy and looked like you could scale up, and you'd slowly step up until you could replace version 1. But we don't have time for that, so I'm just going to replace our routing rule with a new one, which just sends everything to the new version. And now it's all at the new version. And you can see that reflected in the routes as well. So there's 0% being sent to v1. So that was pretty much the entire demo. The point of it wasn't really to say, like, write down these steps and you can call these APIs and figure things out. It's more of the principle of being able to look at the configurations of these different proxies in order to debug your system. So just to recap, what your service mesh really is at a simple level is it's a bunch of proxies talking to a bunch of proxies, and they're all configured by a data plane. And then sometimes it can be really useful when you're debugging a scenario like this in a service mesh to look at the perspective that each of your services has inside that service mesh by looking at the configuration of the proxy that it talks to when it's talking to all the other services. And just to touch on the thing I started with, Magic is great, but a little bit of understanding really goes a long way in terms of debugging issues when you hit them. Moving on to the future for Istio. Our next release, whenever that comes out, is going to have a huge amount of changes. So right now, all the envoys use the version 1 API for obtaining new configurations, and it's written in REST. It's all RESTful, so it's very easy to call the APIs yourself. But it's also, it's inefficient because you have to send the entire state to the proxies, and it's also they're polling instead of, in the new version, it will be pushing. And it's going to be using gRPC and version 2 of the Envoy APIs. So with version 2, we can now look for specific changes, and only when there's a change that actually matters, we can send it on to the proxies, and only the part of that change that matters is sent onto it. So bad news is that little demo I did, you're not going to be able to do it in 0.8. But good news is it's going to be much better performance, and there's going to actually be a bunch of new tools, hopefully, to debug your mesh, kind of in the way that I showed before this slide in the demo. So I believe Doug.
It's a nice segue. So like you're saying, better visibility is coming, and one of the command line tools that will help is we have a tool called Istio Control, and in 0.8 there'll be a proxy config command that you can provide a service name, and it will go and pull all that information that you saw them step through in multiple steps, so that you can look at it all at once without having to know APIs and do all the copy pasting of names from different parts of the config. And I think that's going to be pretty valuable as you try and understand why a proxy is behaving and why routing is acting the way it is. There's also going to be a metrics command that we've added as sort of an experimental thing, so that from the command line you can just see, all right, here's what's happening across these services. This is where traffic is hitting, and you could do something like see the difference between V1 and V2 of a service, depending on how you label things. There's also been some work that's been committed already that should be in the next release on adding pages, UI pages for each of the Istio components, and also is available to link into other libraries that allow you to control behavior of an individual instance of something. And this will be useful for turning up logging scopes, like I mentioned at the beginning, which I find useful in debugging for targeted parts of an application, as well as seeing the metrics for that particular instance, and memory and CPU consumption, et cetera. And then as far as telemetry, typically in Istio, a lot of the telemetry is collected server-side, and that's great if you're concerned only about your service and how it's behaving, but it doesn't help understand what clients are seeing and if there are other things that are happening before traffic arrives at your service. So there is work going on right now to add client-side telemetry and add metric support so that you can see the difference between client and server for a given service. There's also design work going on to support telemetry around config, especially as config rollout and errors around config, so that we can make that exposed in the same way and in a first-class way throughout Istio. And there's always work on more adapters that can push this information to wherever you need it, so that you can do further analysis. And this is just sort of a pictorial representation of what I was just talking through. This is what the alpha version of the control page looks like, and what a command might look like from the command line. Interestingly, I put Istio Pilot just to show that Istio itself is available for inspection with all of these tools, and you can see how it's behaving. And I think that is it. So thank you for coming, especially at the end of the long day. And yeah, if there are any questions, please fire away.